Alright, hello Miss Coley and fellow students. Today I'll be making a video on everything I have learned about factoring in grade 10 quadratics. So first of all, let's talk about what a factor is. A factor is basically a number that can multiply with another number to give you the final product of what you are looking for. For example, in this case, the factors of 3 are 1 and 3 because 1 and 3 can multiply to give you 3. Also, many numbers have more than one factor. For example, the factors of 12 are 1 and 12, 2 and 6, and 3 and 4. Because all these numbers can be multiplied together to give you 12. Now, factoring. Let's talk about factoring and why do we use it and when do we use it. So factoring is very useful if you want to graph a parabola. This is because factoring will give you all the 5 main key points you need to graph a parabola. These points are the x-intercepts, axis symmetry, and optimal value. In other words, the vertex. So when you factor, you will get the x-intercepts. With the x-intercepts, you can get the axis of symmetry by averaging out the zeros. With the axis of symmetry, you can get the vertex by plugging it into the original equation. Now, finding out the vertex is really important because in many problems, it is very useful. For example, in word problems, it can help give you the maximum or minimum, or in other problems, it can just help you graph the main points. Also, factoring is also helpful if you want to simplify an equation or expression. This is done by common factoring. And talking about common factoring, here it is. Now, common factoring is basically simplifying an expression or equation. For example, if you can notice here, 8, 24, and 144. These are all fairly large numbers. If you want to simplify it to make your life easier and get this, if you can notice here, the numbers are much smaller and much easier to work with, you have to common factor. And to common factor, there are certain steps involved. For example, the first step is to notice the coefficients to see if they have a GCF that can be factored out. Now if you look at this equation here, the coefficients are 8, 24, and 144. And if you notice the similarities between these numbers, the similarity is that each of them can be divided by 8. Now the reason they can be divided by 8 is because 8 is their greatest common factor. So as said in step 1, we found the greatest common factor, and now we have to factor it out. That's exactly what I did here. I factored it out by taking out the number and putting it outside a bracket. Now we have common factored it because now we clearly have a simplified version of this expression. Now once you have the expression, you can go on to solve it depending on what type of trinomial it is, either simple or complex. Here we have another example. So the expression reads 2x cubed y to the power of 8, 6x4 y squared plus 10x5 and y10. Now this is where common factoring is really helpful because right now this expression is a mess. And if you want to simplify it, again we follow the steps, and the steps are right here actually. It says notice the coefficients to see if they have a GCF that can be factored out. 2, 6, and 10 can all be divided by 2, and the 2 is the GCF in these coefficients. So we put 2 on the outside. Then step 2 says notice the variables to see if they can be factored out. In this case we have the same variables x, 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 and they're all exponents. So that is good. And the next step is to see which one is the greatest common factor. The exponents are 3, 4, and 5. And in this case, 3 is the maximum number that can go into 3, 4, and 5. It's kind of like creating a remainder. Now, since 3 is the largest number that can go in 3, 4, and 5, we put 3 outside, so it becomes 2x cubed so far. Then we go on to the next variable, which is y. We notice that there are 3 y's, and the exponents are 2, 8, and 10. Now, the largest number that can be divided by 2, 8, and 10 is 2, and that's because 2 is a GCF. So we put it on the outside, and now on the outside we have 2x cubed and y squared. And the last step is, actually the third step is, once you have found the common factors, place it outside of the bracket. We have done that right here. And the last step is simplify the rest of the remaining terms and put it into factored form if possible. So when it says simplify them, that means take all of them and put them into the bracket. And that's exactly what we've done here. And it says put it into factored form if possible. As you can see, here it was possible, but here it is not. So we'll just leave it as it is. Now, some key points to take in when we're common factoring. Every equation you encounter, check to see if it can be common factored. And that makes sense because if you want to try to make your life as easy as possible, you know. And the second key point is only common factor if all terms can be simplified. And for example, what that means is that you have to notice the variables. As you can see here, there are 3 x's and 3 y's. If there was 2 x's and 1 z, you wouldn't want to common factor that out. So the third key point is, after you have simplified, choose a method of factoring depending on the trinomial, simple or complex. Now the second type of common factoring is binomial common factoring. First of all, let's talk about what a binomial is. If you can see here in the example, if I cover this up, k squared, if I cover the 8 as well, k squared is a monomial. If I cover the 18, but I leave out k squared minus 3k, this is a binomial because it is 2 terms. Bi means 2. And here we have k squared minus 3k minus 18. This is a trinomial because there are 3 terms. That's where tri comes from. So back to what we're talking about. This is a binomial because there are 2 terms. This is one term, this is one term, and they're connected by the brackets. Now, I don't know if you have noticed this, but here there are 2 of the same things right here. That is what's important about binomial common factoring. You have to notice what is the same. 4xy minus 3 and 3y minus 3. Here there are 2 similarities, y minus 3. So what we do is that we common factor that out. So we have y minus 3 in one bracket, and what we do is we gather the remaining terms. It's supposed to be 4x plus 3. So we get 4x plus 3. The second example, we have 3x, x plus 5, and negative 2, x plus 5. We notice that there are 2 of the same terms, x plus 5. So we put that in one bracket. And then we have 3x minus 2, and we put that in another bracket. Now, third example is the same thing. Y plus 9, y plus 9. It's the same, so we put in one bracket, and we put 7 minus 2y in another bracket. Now, steps to solving binomial common factoring. In the binomial expression, find out which terms are the same. We've done that right here. Once you found that binomial, place it in one bracket. We've done that. And put the remaining terms in another bracket. We've done that right here. Now, factoring simple trinomials. Now, this is a simple trinomial right here. The reason this is simple is because the coefficient here, which is a 1, invisible 1, which is 1 basically. If there's a coefficient greater than 1 here, then it would be a complex trinomial. But right now, it's a simple trinomial. And the method we use to solve simple trinomials is a product and sum method. The product, if you notice in the trinomial here, is the constant term, or the one without a variable or exponent. And the sum is the one that has the variable. Now, to solve this, we have to find 2 numbers that will multiply to give us 6 and that will add to give us 5. And in this case, the numbers are 3 and 2. And I got those numbers by finding out the factors of the product. The factors of 6 are 3 and 2 and 6 and 1. I didn't write that because I found out that 3 and 2 works. And I know that this works is because 3 multiplied 2 equals 6 and 3 plus 2 equals 5. So I know that these are the right numbers. So once you have found the right numbers, you just put it into factored form. Now, example number 2. Again, we have a simple trinomial, but in this case the product is 12 and the sum is 7. Again, it's 12 because there's no variable here, and the sum is 7 because it is a term with a variable but without an exponent. So again, what we have to do is find the factors of the product. The factors of 12 are 6 and 2, 4 and 3, and 12 and 1. 6 and 2, they do multiply to give us 12, but they don't add us to give us 7. They add to give up 8, so we don't need that. 12 and 1 adds up to give us 13, but we need 7. 4 and 3 adds up to give us 7, so that's how we know this is the right factors. So we get the factors and we put them into factored form, as done here. Now factoring simple trinomial. The steps are: find the product and sum of the trinomial and write it down. Find two numbers that multiply to give product and add to give the sum. And once you have numbers, put them into brackets. Make sure variable goes first. Also, as I said before, a simple trinomial is only simple if there is no coefficient greater than 1 in front of the x squared term. The product is always a number that doesn't have a variable attached to it. In other words, it is a constant term. And the sum of the trinomial is a term without an exponent. In other words, it is the bx term. And the reason I say bx term is because this is a general equation of a trinomial. A squared plus bx plus c, where a squared is the x squared term, bx is a sum, and c is a constant / product. Complex trinomials. As we looked at simple trinomials, we found out that there's a 1 here. In this case, however, complex trinomials have greater than 1. Obviously 3 is greater than 1, so that makes it a complex trinomial. When we have a complex trinomial, we want to use a chart method. And the way we use a chart method is by finding out the factors of the x squared term and putting in the first column. As we saw in the beginning of the video, 3 and 1 are the factors of 3, so we put it right here. We also put an x so we can get x squared. So, and after that, after the first column, we have to find the factors of the product. Again, a reminder that product is the c term, or the one without the variable. So once we do that, we have to put it like this: 2 and 1 and 1 and 2. The reason it's like this is because if you crisscross multiply, which is what you're supposed to do, you will get different answers if you do not do this. For example, 3 multiply 1 equals 3, x multiply 2 equals 2, and the answer you get is 5, and that's exactly what we want. However, if you do 3 multiply 2 is 6, x multiply 1 is 1, 6 plus 1 equals 7, that does not give us 5. So clearly, even though they are the same numbers, the order matters a lot. So again, in the case of simple trinomials, once you found the right factors, you put it in factored form. And the reason this 3 is here is because you cannot eliminate a number from an expression. You can do it in an equation by taking to the other side, but in this case, in an expression, you cannot do it. So the 3 is still here. Again, we have another example: 6x squared plus 25x plus 14. Now, again, we take the factors of the x squared term and put it into the first column, and we find the factors of the c term, or the constant, and we put it into the terms after that. And again, we have the opposite order, and we found out that 7 multiplied 3 equals 21, 2 multiplied 2 equals 4, 21 plus 4 equals 25, and those are the right numbers. And we put it into factored form. So some key points to notice about complex trinomials. A complex trinomial has a coefficient greater than 1 in front of the x squared term. Sometimes there might be a number that has more than one factor. In that case, draw out two charts. Example, 3x squared plus 5x plus 2. In this case, there's only one factor or two factors, 1 and 3. However, in this case, you only have to draw one chart. However, in this case, you have a bigger number, means that there are more factors. Example, the factors of 8 are 2 and 4 and 8 and 1. So in this case, you have to draw two charts, one for 2 and 4 or one for 8 and 1. Difference of squares. Difference of squares. Okay, so one way you notice an expression is difference of squares is if both terms can be squared. For example, if you look here, x squared, if you square root it, you get x. 49, if you square root it, you get 7. Actually, let me clarify that. All numbers can be square rooted, but to know if it's a difference of squares, it has to be an even whole number if you want to square root it. In this case, if you look here, it is perfect square root because there are no decimals. So that's how you know it's a perfect squares. So once you find the square root of the terms, put it into factored form. Put it in, and the equation has to be a plus b and a minus b. Sorry about that right here. A plus b and a minus b. That's the form that you put it in. Here's another example, 9y squared minus 64. We know that the first term is a positive perfect square because if we square root it, we get 3y, an even whole number. And if you square root the second term, 64, we get an even number, which is 8. So we have confirmed that this is a difference of squares question by showing the steps right here. Once we found that number, we put it right here in factored form. Now steps. Take square of each term and place it in two brackets. We've done that right here. And the form of the bracket should be a plus b and a minus b. As I said before, to know what's the difference of square problem, make sure each term has a square. And these are examples of difference of squares. It can also be in this case. In this case, if you have it like this, you have to expand it. Factoring by grouping. Now, factoring by grouping is very similar to binomial common factoring. Because as you can see here, we have the same scenario. Two things are the same. But factoring by grouping is also similar to common factoring. As you can see here, we have two terms and we common factored it out. We common factor the 2 because the coefficients are the same and the GCF is 2. So we factored out, common factor the 2. And we realized that there are two same terms, x and x, with both exponents. And we realized that 2 can go into both of them, at least one. So we put x squared, and we put in the remaining terms. So if we common factor this out, we get x minus 2 remaining, because x squared minus x3 equals 1x. So we have 1x right here, and 4 divided by 2. Negative 4 divided by 2 is negative 2. That's what's remaining. Also here, we've common factored this out. We realize that 3 goes into 6 twice. Goes into 6. We realize that 3 can be common factored because it is GCF of both terms. So we put 3 here. And we realize that x is remaining. So we have 1x. And negative 6 divided by 3 equals negative 2. And once we have that, we can factor it out. Factor out the same terms. X minus 2, x minus 2, we have it right here, and we put in the remaining terms. Same scenario, we realize that a and a are similar, so we factor that out. We have b minus 2c remaining, and here, same thing, 3 is a GCF of both 3 and 6, so we factor that out, and we leave b minus 2c. So we binomial common factor it out, and we get this in factored form. So steps, find out what is common in a pair. We've done that, 3, 3. Put the common factor outside the bracket. We've done that. Whatever is common, put in one bracket. What's common, put in one bracket. And put the remaining terms in another bracket. We have done that. So some key things to notice: you should always deal with one pair at a time, and you should get the same terms in the brackets. If you don't, something is wrong. As you can see here, in both scenarios we got the same thing: x minus 2, x minus 2, and b minus 2c, b minus 2c. If you don't get this, that means something is wrong. Now finally we have factoring perfect squares. Now to find out if a expression is a perfect square problem, make sure that each term can be squared, and you do that by showing your work right here. I noticed that 16 is a perfect square because if you square root it, you get 4, and I wrote that 4 multiplied 4 equals 16. And second case, we noticed that 9 can be square rooted because 3 multiplied 3 equals 9. So we found out that this is a perfect square problem because the first term is a positive perfect square and the second term is also a positive perfect square. Then what you do is you get the square root of the first and last term, you carry it on to the middle term, and you multiply that by 2. That's why we have it right here. You multiply by 2. Now this is because of the equation right here. The equation, the formula you have to have it in is a squared plus 2ab plus b squared equals a plus b squared. As you can see here, we have a squared plus 2 multiply a plus b, 2 multiply a plus b, 2 multiply a plus b, plus b squared, and then it has to equal to a plus b squared, and it does so right here. So we have figured out that this is a perfect square problem. Here is another example. We found out that 4 can be square rooted to 2, and 49 has a square root of 7. We carry it on to the middle term. We write it in the general formula, which you have to remember, and then you put it into factored form. So steps: find the squares of each term. We found that. Take the squares of the first and last. You have to remember this. It's only the first and last terms, and carry it on to middle term. First, last, we found it, carry on to middle term. Then rewrite the equation in factored form. We've done that. So last point, factoring perfect squares. To check if the trinomial is a perfect square, make sure the first term is a positive perfect square, the last term is a positive perfect square, and the middle term is twice the product of the square root of the first and last term. For example, 16m squared plus 24m plus 9. 16m squared is a positive perfect square because 4m times 4m equals 16m squared. 9 is a positive perfect square because first of all it's positive, and second of all it has square root of 3. So the first term product is 4, second term product is 3, so multiply that.